Hello, in this video, we are going to look at geometric series. So in the sequence section, we saw that for a sequence r to the n, that was a geometric sequence, this sequence converges if if r is between -1 and 1 inclusive, and converges to 1 if r equals 1, and 0 if the absolute value of r is less than 1. So we have this information about geometric sequences. We are going to use this knowledge of geometric sequences to help us figure out when a geometric series converges. Now, recall, to tell if a series converges, we're going to look at the sequence of partial sums. So, looking at the sequence of partial sums, n equals 1 to k of our sequence a sub r to the n minus 1. This sequence is equal to a plus ar plus ar squared plus ar cubed plus so on until we have ar to the n, the k, minus 1. Because the sequence of partial sums does stop eventually. And now, because we have this common ratio, we're actually going to look at another sequence. And that sequence is going to be the sequence where I multiply by r. So I'm going to take my series and I'm going to multiply it by r. So that sequence of partial sums now becomes ar plus ar squared plus ar cubed plus so on until we'd eventually have ar to the k minus 1. And because we have this additional r, we'll also get all the way up to ar to the k. It's this entire sequence before, but everything gets multiplied by r. Trying to find some different things to work with, we're going to subtract everything because these two series of the partial sums have a lot in common, right? Each of these rows they have in common. So subtracting them will make all of those go away. We're going to subtract. This will give us the series the partial sum n equals 1 to k, r to the n minus 1, minus r times that same partial sum, which is equal to, everything cancels out, except for that first and last term, a and ar to the k. And it's subtracting, I know it's plus here, but remember we're subtracting this second line. These are just numbers, especially since they are just a partial sum. There is a finite number of things being added up. So we're going to factor that out to get the series n equals 1 to k of ar to the n minus 1 times, when I factor that out of both of these, I have 1 minus r. meaning this series of partial sums or sequence of partial sums that we've been trying to find a formula for is dividing by 1 minus r, a minus a r to the k over 1 minus r. First thing I'm going to note here is r cannot equal 1. Because if r equals 1, we are dividing by 0. So we are ruling out the case where r equals 1 from our geometric sequence series being able to converge. So the sequence converges at 1, but so we don't divide by 0. The series cannot converge at r equals 1. Now, looking at the limit, because the definition of the series convergence, which is what we're trying to find, is when the limit of the sequence of partial sums has a value. So we're going to look at this limit as k goes to infinity of the sum n equals 1 to k of a r to the n minus 1, which is equal to the limit as k goes to infinity of a minus a r to the k over 1 minus r. The only thing controlled by the limit here is that a r to the k. And we know from geometric sequences that the limit a r to the k equals 0 if the absolute value of r is less than 1. The limit as k goes to infinity of a r to the k equals 1 if r equals 1. But remember, we've ruled that case out. We're saying that one can't happen. And the limit k goes to infinity, a r to the k diverges otherwise. So if r is bigger than, meaning this limit only exists when the absolute value of r is less than 1. Do that in a different color. And if the absolute value of r is less than 1, this circled term goes to 0 because the limit a r to the k equals 0 in that case. So this will equal a over 1 minus r when the absolute value of r is less than 1. But that limit doesn't exist in any other situation. So that gives us these geometric sequences converge if the absolute value of r is less than 1, and it converges to a over 1 minus r. It diverges if the absolute value of r is greater than or equal to 1. And now we have what is known as the geometric series test, where if we have a geometric series, we can quickly tell if it converges or diverges by looking for the absolute value of r. And we will take a look at some examples of that in the next video.